A long-lost ice sheet could predict the future of New York City, one in which Lower Manhattan and Coney Island are perpetually submerged. Scientists are rethinking what we knew about a vanishing ice sheet, and that could spell trouble for New York City. Evan Howell published. On October 29, 2012, Superstorm Sandy unleashed a 14-foot wall of seawater into New York City. Regionally, the storm inflicted $50 billion in damage and opened a window into the future. By mid-century, flooding like this could become routine. While the Statue of Liberty may not be submerged, low-lying places like Ellis Island could be underwater by the year 2100. Sea level rise alone could approach Sandy's 2012 high water mark. The New York City Panel on Climate Change, NPCC, predicts up to 5.5 feet of local sea level rise by the year 2050s and 9.5 feet rise by 2100. That's about 10 feet. However, new evidence from Earth's past suggests that these dire scenarios may be likely, and perhaps even conservative predictions. Around 2.6 million years ago, the planet descended into the Quaternary period of alternating glacial interglacial cycles that occur roughly every 100,000 years. These cycles, driven partly by the planet's eccentric wobbles, tweaks the amount of solar radiation reaching Earth. During cold glacial cycles, ice sheets sprawled across Antarctica, Greenland, and North America, locking away water and lowering sea levels. In warmer interglacial times, the ice retreated and oceans, of course, rose. The key to understanding today's rising seas may lie in the last interglacial years, 129,000 to 116,000 years ago, when global temperatures peaked at 1.8 to 3.6 degrees Fahrenheit, or 1 or 2 degrees Celsius, above pre-industrial levels. Considering we're currently 2.7 degrees Fahrenheit, or 1.5 degrees Celsius above pre-industrial levels, the last interglacial could presage changes in the coming decades as human-caused warming continues. For years, researchers believed North America's Laurentide ice sheet disappeared very early in the last interglacial, but new evidence suggests the Laurentide lingering thousands of years after that. If true, this fundamentally alters understanding of where and how quickly ice melted back then. New models suggest that if the Laurentide persisted, Antarctica likely melted more and more rapidly than previously thought, and that has worrying implications for future sea levels. We all want to understand how small Antarctica's ice sheet became the last time Earth reached similar temperatures. Roger Creel, geophysicist at Woods Hole Oceanographic Institution in Massachusetts, who studies sea level changes, told Life Science, sea level projections may be too low if Antarctic melt was underestimated. Sea level rise projections. Global seas have risen as little less than 1 foot since 1880, with a rate doubling since 2006. Another quarter meter is all but certain by the year 2010. But that's likely an underestimate. Scientists expect accelerating polar melt. The problem is pinning down how much the poles will melt. Projected sea levels is similar to forecasting a storm's path. We're trying to predict the future from past data. Unlike with a modern storm, however, very few of our sea level records are definitive. Direct measurements taken from tide gauges and satellite data captured just a blink of geologic time. The Liverpool tide gauge, one of the longest running records, spans just 300 years, or 0.01% of the Quaternary. Predicting the future based on only direct measurements then is like a bit like guessing a novel's ending from just the first few chapters. Further back in time, the record gets murkier. Ancient glaciers obliterating much of the physical evidence that could help explain past climate changes. Where direct evidence survives, say in ice cores or rubble piles, dating can be challenging. What's left is a patchwork of clues, fossils, sediments, and ancient shorelines that scientists piece together like detectives. And one person deciphering these ancient clues is Andrea Dutton, University of Wisconsin-Madison geologist. Far from Antarctica, jagged limestone scarps rise from the turquoise waters of the Caribbean. Beginning about 129,000 years ago, ice melted, seas swelled, and reefs grew to chase the sun. These reefs preserve evidence of sea level fluctuations like mosquitoes in amber. Receding waters marooned these fossilized reefs on land, leaving them for researchers like Dutton to study. And he spent years tracking coral growth and death cycles to untangle how seas rose and fell during the last interglacial period. Researchers still debate how high or fast seas rose, with estimates ranging from 6.5 to 33 feet above present levels. And his work has taken the scientists across the globe, and what she found is perplexing. In the Caribbean, for example, sea levels peaked multiple times, whereas Chilean shores show no such patterns. The public generally imagines uniform sea level rise, a meter in Vancouver, a meter in Sydney, but that a uniform rise is a figment of our imagination, Dutton said. In fact, deciphering ancient sea levels is maddeningly complex. So researchers initially attributed mysterious sea level shifts, multiple peaks in some areas and regions, and falls in others, mainly to the melting and regrowing of Greenland and Antarctica during the last interglacial. The lingering Laurentide, Creel set out to explain these mysterious sea level patterns as part of his doctorate dissertation. The Laurentide remains central to the big question: how high and fast will seas rise again? Creel frames it like an accountant. Scientists typically budget interglacial sea levels from known suspects: ocean thermal expansion, Greenland, Antarctica, and mountain glaciers. But the Laurentide adds a new line to the ledger. Antarctica is probably more vulnerable than we thought, Creel said. If the Laurentide lasted longer, it may have masked how much Antarctica melted. For years, some scientists suspected a long-lived Laurentide, but hard evidence was scarce. That changed in 2022 when researchers studied North Atlantic sediment cores found in signs of an enormous ice dam collapse 125,000 years ago, implying large amounts of North America ice. The key element they found in a study published last year was a process called isostatic adjustment. Ice sheets press down on the land. When they melt, the ground rebounds, altering Earth's rotation and gravity. It's like sitting on a cheap mattress, paleoceanographer Natasha Barlow said. It sinks under your weight, and then the other end rises, just like how ice compresses the Earth. When it melts, the mattress rebounds, affecting sea levels differently depending on where you are. Now, these findings help explain ancient sea level puzzles. They also hint at what's coming. If Antarctica melts faster than expected, places like New York will bear the brunt, while global seas may rise 6 feet by 2100. New York could see a 10-foot rise. So all eyes on West Antarctica. Most of Antarctica ice lurks below sea level. It's more vulnerable to melt than Greenland's land-based ice, they said. Now, from the past comes the future. If recent findings hold up, significant West Antarctica melt is imminent. Even our gloomiest predictions may be optimistic. New York already experienced sunny day flooding. By storm surges would magnify the damage. And new insights from the last interglacial could lend weight to the scenario, which was once dismissed as extreme. And this is by Evan Howell on Life Science. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.